So this is the 2017 paper 2 from Junior Cert Higher Level, and we're looking at question number 8. Part A says, the diagram below shows two right-angled triangles, ABC and ACD. They have right angles at B and D respectively, and the length of the line AB is 10, AC is 12, and AD and DC are equal to each other in length, and they're both denoted as x, the value x. Okay, so we can see all this here in the diagram, and it tells you the angle BAC is marked y. So this is here. So good idea just to confirm each of these facts here on the diagram as you're reading it. Part 1 then says, use trigonometry to find the size of the angle y. And give your answer correct to one decimal place. Okay, well, seeing as there's two right angled triangles here, I'm just going to highlight them in different colors just so we're clear. So you can see triangle ADC there, and we'll just go with another color then for the triangle ACB, which is here. Okay, so it just makes things nice and clear. Right, well, part 1, okay, it said use trigonometry to find the size of the angle y. Okay, so we're looking for this angle here, angle y. Okay, well, in the blue triangle here, you've got this angle y, it's a right angle triangle, and you've got this side which is adjacent to y, and this side here which is the hypotenuse of the triangle. So if you think about SOHCAHTOA, you've got the adjacent and the hypotenuse, so that's going to be cos. SOHCAHTOA. So the cos of the angle y is equal to the adjacent over the hypotenuse, which is 10 over 12. That's the adjacent there, and that's the hypotenuse. So if the cos of the angle y is 10 over 12, well, that means the angle y is the inverse cos of 10 over 12. So if we do that in our calculator, press the shift button, shift cos 10 over 12. Make sure your calculator is set to degrees, got a D at the top, and the answer to that is 33.557, and on it goes, degrees, right? But you want your answer correct to one decimal place, so 33.557. One decimal place, we look at the second digit after the decimal. This 5 knocks the previous number up, so it's going to be 33.6 degrees to one decimal place. Okay, and that's the end of part 1. Part 2 then says find the value of x and give your answer correct to 2 decimal places. Well, x, if we remember, x was the length in this isosceles triangle here. It's the length of both these sides, AD and DC, which are the same. So if we look at this yellow triangle, it's a right angle triangle. We're looking for the length. So we can apply Pythagoras here. You could label this A, B, and the hypotenuse is C. And you know that a squared plus b squared is equal to c squared. So that would mean that x squared, which is a, plus b squared, b is also x, is equal to c squared, which is 12 squared, wasn't it? Yeah, 12 squared. Okay, so x squared plus x squared, well, that's 2x squared. And that's equal to 12 squared, which is 144. So you could divide both sides by 2, the most straightforward way, and that's 72. And then x then would be plus or minus the square root of 72, but of course we're dealing with length, so we know it's going to be the positive value, so x will be the square root of 72. So that's the length of x. However, they want the answer correct to 2 decimal places. So on your calculator, when you get root 72 or type it in, press the SD button and it will give you root 72. as a decimal, so it's 8.4852, and on it goes, but we only need this correct to 2 decimal places, so the answer would be, we look at the third digit after the decimal. This 5 knocks the previous 8 up to 9, so it'll be 8.49. That's going to be the value of x. Okay, and finally part B. The diagram below shows 2 different triangles, PQR and RSP. So you see the 2 triangles there. The points R, S, and P are on the circle K, and Q is the center of the circle K. The size of the angle QPR is 22. The angle PSR is marked T. So that's it there. So again, confirming all this information in the diagram. It's good practice, kind of slows you down, gets you in the right frame of mind. And then it says find the size of the angle T. Show all of your working. All right, so we're looking for the size of this angle T. Okay. Well, there's a circle theorem. There's a few ways you could do this, but there's a circle theorem here that we need to kind of recognize first of all, and it's that this angle here, this reflex angle, is equal to 2 of these angles. Okay, because this angle is standing on this arc, and this angle is standing at the same arc. So the angle at the center is twice the angle at the circumference standing on the same arc. Okay, and the arc there, just to make it clear, it's hard to see because it's a reflex angle, but the arc in this case is this arc. So because they're both standing on this arc, this angle here in blue is 2 times this angle here at T. Okay, so that's the circle theorem that I've spotted. Okay, but I don't have enough information to begin from there. So what do I know? I know this angle here is 22, and I know that PQ and QR are the same. They're both radii of a circle. So this angle here is also 22 degrees. So if I look at the triangle PQR, you have 22 and 22 is 44. That means that this angle here will be 180 minus the 44, which gives me 136 degrees. And if this is 136 degrees, well, the angle outside here, both of them must make 360. So 360 minus 136 is 224. So this angle out here is 224 degrees. And if this is 224, well, the angle T is half that, which is 112 degrees. So the angle T is equal to 112 degrees. Okay, so the working there, I suppose, you don't have to give the reasons, but the working is on the diagram. And that's the end of the question.